Hey guys, very good evening everyone, and welcome to yet another session of our domain analytics series that is being taken care by 360DigiTMG. And from the past few days, we have been discussing about the domain related to sports. So we have been extensively discussing about our sports analytics for the past few days. We have seen how can you make a career in your sports analytics, or if you choose your sports analytics as your domain, what are the traits or what are the qualities that you should possess? All these things we have seen. We also saw, how to do the ED on a particular data set pertaining to our sports analytics. We did the data pre-processing on that. We also saw how to perform your, clustering technique. Today, specifically, we will be talking about decision tree classifier. How can we use the decision tree in our use cases for sports analytics? And based on that, we will try to find out that whether a particular team is going to win the match or not. We will compare that with the various other, classifier techniques as well as your XG boost and all these things. And we will see in the comparison that whether our decision tree is giving us the better accuracy or not compared to the other classifier techniques. Okay. So let us move ahead with this session. So today's agenda is going to be, of course, we first of all want to know, what is decision tree, what are the uses of decision tree components, use of decision tree in sports analytics, and hands-on with use case in your Jupyter. All this is our agenda for today. So a decision tree is a supervised learning technique, guys, that can be used for both your classification and regression process. A decision tree is a graph that uses a branching method to illustrate every possible output of a specific input. Decision trees can be drawn by hand or created with a graphics program or a specialized software. Informally, decision trees are useful for focusing di- discussion when a group must make a decision. As if we talk about a decision tree or if we talk about a tree, this is how your tree looks like. It will be having leaves and it will be having the roots. This is your leaf, branches, and roots. Whereas if we talk about decision tree, in this first we have our root node, then we have our branches, and then we have our leaf node. So as we know that decision tree can be used for both your classification and regression problems, but mostly it is preferred for solving our classification problem. It is a tree structured classifier where internal nodes represent your features of a data set. Branches represent the decision rules, and each leaf node represents the outcome. So your root node, it is going to represent what? Features. of a data. Branch node is going to represent your decision rules, whereas your leaf node is going to represent the outcome or your out. That is nothing but your y variable. So as we discussed that in the decision tree, there are some nodes, and primarily it is your, decision node or your leaf node, means your root node and your leaf. Your root node are used to make any decisions and have multiple branches. And leaf nodes are your output of those decision and do not contain any further branch. The decision or the test are preferred on the basis of your feature given in a data set. Yeah. And in order to build a tree, we use an algorithm called as your cart algorithm, which stands for classification and regression tree algorithm. Classification and regression tree algorithm. When we talk about your decision tree, it simply asks a question. Based on the answer yes or no. And it further splits the tree into your subtrees. Now, the question arises, why do we use your decision tree? So what happens, guys, when we talk about, machine learning? There are various algorithms in machine learning. So choosing the best algorithm for a given data and problem is the main point to remember while creating a machine learning. Two main reasons, if I were to say that, if someone asked me, hey, give me the two reasons why do we choose a decision tree, I would say the first reason is decision tree usually mimic human thinking. Ability. For what? While making decisions. As in, suppose you are driving a car and say a person or an object comes in front of you. There will be various factors that you would examine, before applying the brake. Whether you have to apply the brake, yes or no. Whether you have to apply the brake fully or you just need to, slow down the car. Various factors. So it becomes very easy to understand. Second, the logic behind, the decision tree, whatever decision it is taking, it is very easy to understand because it shows tree-like structure. So a decision tree are used for handling non-linear data sets effectively. The decision tree tool is used in the real life in many areas, such as engineering, civil planning, law, business. even in the sport. And decision trees can be divided into two types. One is a categorical variable and continuous variable decision tree. Further, talking about your decision tree, we already discussed about your root. There are some terminologies that you should be aware of. First is your root node. Root node is from where the decision tree starts. It represents the entire data set. Which further gets divided into two or more homogeneous subsets. Second, you have leaf nodes. Leaf nodes are the final output, or you can say these are your final output nodes. And the tree cannot be segregated further after getting a leaf node. Once you reach your leaf node, there couldn't be more. Decision tree, guys, mainly works on a concept of divide and conquer. Divide and conquer. So it keeps on dividing your data set, but as soon as it reaches your leaf node, no further division of your data set is possible. Third, these are some terminologies what I'm telling you that you should be aware of while dealing with a decision tree. Another thing is splitting. Splitting, guys, it is a process of dividing the root node into what? Into subnodes according to the conditions that are being given. Whether a person is salary or whether a sports person is fit or unfit. If he's fit, what is the age? If the age is this, then how many matches has he played in this season? And based on that, you are going to predict whether that particular match this player is going to win or not. So the plus point with the decision tree is it tells you exactly the reason for which you get an answer. If a person is going to win a match, then what are the reasons associated with it? Or what are the reasons based on which you know that person is going to win the match? If he's not going to win the match, or if a team is not going to win the match, what are the various reasons associated? That is the beauty of your decision. Another branch node. Branch node or subtree is a tree formed by splitting the root node. Another term is your pruning. Pruning is a process of what happens. Suppose you have a plant at home, right? If you have a plant at home, pardon me for my drawing. I have a very bad drawing, so don't focus much on the drawing. Try to focus on the concept. So what happens if you have a tree at home, or say if you have a plant at home? Time and again, you keep on pruning it. You keep on cutting the extra bushes or branches that are coming out. Try to give it a shape. So pruning is the process of removing unwanted branches from the tree. Okay. Another. One more terminology that you will come across is a parent or child. What is this? The root node of a tree is called as your parent node. This is your parent. The other nodes that we have is nothing but your child node. So these are some of the terminologies that you should be aware of while dealing with the decision. Why do we call it a decision tree? In decision analysis, whether my team is going to win a match or not, whether this particular player is going to, make a century or not. A decision analysis or in decision analysis, a decision tree can be used to visually and explicitly represent the decision and decision. So this is the person X. Say his age is 20 to 25, 25 to 37. Say he played around 12 matches in this season. In all the 12 matches, he made more than 5 centuries or less than 5 centuries. If his age is 35, how many matches he made? And out of those matches, how many centuries? Based on various factors, you end up getting a leaf node for each instance. Yes, no, no, which tells you exactly the reason whether a person is going to win the match or not, or whether he's going to make a century or not, based on our sports analytics story, the thing I'm saying. Right? So, as the name goes, it uses a tree-like model for decision. The same thing which I was telling you. If you try to find it, this is the root node, these are the branches, you end up with a leaf node. Right? A decision tree diagram is a type of flowchart that simplifies the decision-making process by breaking down different paths of action available. Decision trees also showcase the potential outcome involved with each path. So if this is a player X, his age is this, and this, then he will end up winning the match. All of the age is this, and these parameters are there, he will end up losing. So it showcases the potential outcome involved with each path of action. Yes. So what happens? In decision tree, for predicting the class of a given data set, the algorithm starts from where? From your root. This algorithm compares the value of the root attribute with the record, and based on the comparison follows the each branch and jumps to the next node. Now, when it reaches the next node, the algorithm again compares the attribute with other subnodes and move further. This process continues until it reaches your what? Leaf node. The complete process is called as a decision tree. So what happens is you start with your root node, which contains a complete data set. Then you find out your best attribute. So what happens when? If you have this data set, this is a $1 million question. Say this is your input 1, input 2, input 3, input 4, and this is your output 3. Now, based on only one input, your root node could be decided. So which input node you have to choose? The input variable which gives you the maximum information. You will choose that. So, while implementing a decision tree, as I was telling you, the main issue arises that how to select the best attribute for your root node and for your subnode. So to solve such problem, there is a technique which is called as your attribute selection measure, or ASM. By this, we can easily detect the best attribute node for each field. And when we talk about attribute selection measure, there are two popular techniques that are associated with it. One is your information gain. And one is your Gini index. Information gain, as in, suppose you wake up early morning and you see that there's a news flashing. Sun rose in the east. If you try to find out the information in this kind of news, the information for this event is actually 0. What is the new thing? Every day your sun rises in the east. What is the new thing? But if another news flashes, say there was a tsunami in Miami. This is something very rare. So the information for this event, information gain for this event is going to be 1. But if you talk about the probability of this event will be high. Whereas probability of getting a tsunami is very low. So probability related to this event will be 0. In other words, if I were to summarize it, the information gain of an event is inversely proportional to the probability of an event. This is how I would summarize. Information gain, guys, is the measurement of changes in your entropy after the segmentation of a dataset based on an attribute. and it calculates how much information a feature provides us about a class. According to the value of the information gain, we split the node and we build the decision. And once a decision tree algorithm always tries to maximize the value of your information gain. And a node having the highest information gain is a split first. And it can be calculated using the formula. What is the formula for your entropy? Formula for an entropy is probability of yes, inverse probability. So minus log probability of yes minus probability of E. So S over here is the total number of samples we are having. Probability yes is the probability of yes and probability no is the probability. This is how you calculate your entropy. Whereas when we talk about your Gini index is a measure of impurity or purity used while creating a decision tree in the card. That is a classification and regression. An attribute with the low Gini index should be preferred as compared to your high Gini index. It only creates a binary split, and the CART algorithm uses a Gini index to create a binary split. Gini index can be calculated using a formula. Gini index is equal to 1 minus summation of G raised to the power. This is the formula for calculating the Gini index. There are some, okay, even before discussing this, let me tell you the components. Components we have already discussed. Again, the same thing is the decision tree are composed of three main components. That is your decision node, chance node, and end node. The root node is splitting. We have discussed all this. What are the uses of decision tree in the sports analytics? At least some we can discuss. So decision tree helps to clarify the choices or risks or monetary gains and other information involved in the decision. So as a result, the managers of a team can make an informed decision when choosing the alternative that provides the best net gain and whether the net gain is worthwhile to pursue. Using the decision tree, the management can consider various courses of action with greater ease and clarity. The interactions between the present decision alternatives, uncertain events, and future choices, and their results become more interesting. Then there are some advantages and disadvantages when we talk about your decision. So let us first focus on the positive things, advantage. So decision tree, guys, it is very simple to understand as it follows the same process which a human follows while making a decision in the real. Second, it can be very useful for solving decision-related problems. Third, it helps to think the all possible outcomes for a problem. Another advantage is there is a very less requirement of data cleaning compared to other algorithms. These are the advantages. Talking about disadvantages. So a decision tree, you know what we saw This is the root node that gets splitted again. This is getting splitted maybe here, and again this is getting splitted. A lot of split is happening, right? And finally it ends up with your leaf node. And when you have a leaf node, the split stop. So the disadvantage associated with your decision tree is that it contains a lot of layers. And when it is having a lot of layers, what happens is it becomes very complex. When it becomes complex, then what? It will be having overfitting issues. That is a big issue. But if you have a overfitting issue, again, it could be resolved using your random forest. But again, we should consider that as disadvantage. To counter this disadvantage, we use an algorithm called as a random. The more class labels you have, the computational complexity of your decision tree increases. So these are some of your disadvantages that are associated with your decision. Now, coming to our Jupyter node. So here I have used a data set. Let me show you. This is the data set that I have used, and it is having various variables: time, form, round, day, venue, result, opponents, SGXDA, force attendance, means various, inputs. This is the data set that I have used. And team name is also there, season is there, some, I have used this data set. I have imported my required libraries over here. After importing that, I have loaded my data set. And I have said data.head, it is going to show me the first 5 books along with the form. So here I have my 5 rows and the 28 columns that I was having. I said data.tail, then it is showing me your last 5 rows along with the form. Data shape I found it was having 1, 3, 8, 9 rows and 28 columns. Data type, all these things are being shown. When I said data.describe, it is showing me your mean, median, standard deviation, all these things are 25th percentile and 50th percentile. I have included all features, all categorical features for my descriptive analytics over here. So I have my all features over here. And then I started with my data preprocessing. First, I tried to find out whether there are any missing values or not. So I am observing over here in the attendance, I have 696 missing values. In notes, I am having 1389 missing values. DIST is a column where I am having one missing value. So in this way, I found out whether there are any missing values. Now, it is having the most missing values in your dropping column. So what I did, sorry, it is having the most missing values in the notes column, and I'm dropping that. So I'm saying data dot from the data set, drop your notes column. Access is equal to means obviously it is a column, so access is. I am also dropping my attendance over here. Then I was checking for my duplicate value, for which I got the result 0. This is an open data set that I am using. This is an open source data set. Now I'm getting your complete summary for the data set. I said data.info. This is the information I have. I have my date column. I'm converting it into a date time format. So here I have said from using your pandas, convert the date column that you have in our dataset data to date time. I am also converting my categorical values into your numerical values. So for that, I have imported your pre-processing from SQL. And I'm saying use a label encoder dot pre-processing whenever I say LE. LE is a name which I thought would be apt for using your label encoder. And I have used that label encoder on value. On this particular column, I have used my label value. So I am having away, home, away, home, away, home, so on and so forth. In this way, I got my value. Again, I'm converting my categorical values into numerical values. And I'm using your label encoder on the opponent column. Then, considering only hours in the time and I'm neglecting my minutes, I have initialized some parameters that wherever I'm having these kind of terms, replace it as an integer. And you need to do that on a time column that is there into the dataset called as data. The values which you get, store that into an R column which exists into a dataset data. This is what I have done. So in short, what I've done, instead of taking the whole minutes and hours, I am only considering the hours. I converted my days into your numerical values also. And considering only win or loss, leave node, yes, no, true, false, win, loss. So I have considered my win and loss as my target win. So what happens whenever I get one, that means my team is going to win. If I get zero, means it is going to lose. I have used my result column from the dataset data and I have compared it with your win as type integer and I have stored the values into the target column into your dataset data. And when I say data, then I get my results as lose, win, 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 draw, lose, win, so on and so on. Now, I tried building my decision tree algorithm, and for that, I am importing my decision tree classifier from sklearn.tree. I have initialized the parameter. Criteria I have chosen as entropy, random underscore state 100, maximum depth 3, minimum sample least 5. Some parameters I have initialized. And I'm saying that whenever I want to run this particular function, I just need to say CL. Now, I am taking or considering my 2101 data as my training data. So I'm saying that if my date is smaller than, less than this date, consider that as your training data. And I'm trying to find out the shape for my training data. It is having 1107 rows and 31 columns. The data which I'm having after that, I'm taking that as your testing data. So my testing data is 276. The more training data means, the better my machine will learn the pattern. So I've chosen my training data to be more. Predictors I've given as a venue code, opposition code, and R and A. Then I've taken the CLF, which I created over here, and I'm saying run this algorithm. Dot fit means it will run this algorithm on train predictor training data and your target, which is into your training data. So this is what I'm getting, and it is showing predictions is equal to this. Again, I'm saying for the predicted value, these are the parameters that I've given clf.predict on my testing data. So from the sklearn.metrics, I'm importing my accuracy score, confusion matrix, and your confusion matrix as it your yes, no, true, true positive, true negative, false positive, false negative, also called as your cross tab. You perform a cross tab to find your confusion matrix. I'm importing my classification report as well over here. I'm saying use your accuracy score on the testing data target and give me the predicted value. The values which you get is stored into an accuracy. So when I run this, I am getting an accuracy of 63%. If you try to find out your confusion matrix, this is what you will get. Diagonally, if you see, this is the apt value that you should have. Now, this is the accuracy score that I got for my decision tree. I have performed various algorithms for the same data set in order to do the comparison that which algorithm is giving me the best accuracy. So I did my grid search CV as well. So how we did this, I'm not going to explain because it is not related to our terms. Just for the comparison I did. Then I did my random forest classifier. Then I did my randomized search CV. And the thing which I wanted to show you people, yeah, XGBoost also I use various classification techniques at work. And when I came up with my models, so for the decision tree, I'm getting 63% accuracy. Random forest is getting my 62% accuracy. Decision tree grid search is giving me 60%, random forest 60%, XGBoost 60%. If I do the comparison of all the various models or various classification techniques, decision tree is giving me the best result or best accuracy when compared to other models. So this is how, guys, I did my decision tree and I tried to predict whether my team is going to win the match or not, or whether a particular team is going to win a match or not. And if it is going to win or lose or not, what is the accuracy of that result? This is also what I tried to say. So this was all about our decision tree pertaining to our sports analytics for today, guys. Hope this session was enlightening for you people. So keep on practicing. Happy learning, and people who want the data set and codes, they can ping me privately, either on the WhatsApp. And the day when we'll be ending this domain analytics series, I will be sharing all these codes and data sets to you people on your respective email IDs. So again, thank you so much, guys, for joining. Have a wonderful day. Enjoy your day, but keep on learning.